Alrighty, welcome back to APS105. So, to cap off recursion week, we are doing string recursion exercises. So, just to recap, first slide of every single lecture this week is what a recursive function is. So, again, just to drill it in, a recursive function is a function that calls itself. In order for it to be useful, we need two things. We need a base case, which is generally a simple solution that we know that will terminate the recursion, and a recursive step, so reduces that problem to a smaller version of itself. This can be done in multiple steps, like we saw last lecture with the Tower of Hanoi. It doesn't have to be exactly one recursive function call. You just have to break it down into a smaller version of itself, no matter how many steps that actually takes. So, we can do recursion with string functions. That seems to be a common thing on the final exam. So, luckily for recursion with strings, there's generally three major ways to think about recursive functions with strings and reducing the problem to a smaller version of itself. So, one is the first character or the last character, and then your smaller problem is that string without that character. And then maybe you have a smaller string preceding a character, so maybe you look at a character and then take the string before it, or maybe you're looking at two characters enclosing a smaller string, so you can look at the first and the last character, and then argue about the string in the middle of those. So, can we recursively check if a string is a palindrome? So, a reminder, if you don't know what a palindrome is, it's a string that's the same forwards as it is backwards. So, if we're trying to write the function recursively called isPalindrome, we want it such that if the argument for the string is, something like race car, then that should return true. If it's something like, I don't know, A, B, C, A, that should return false. So, I'll give you a minute or two to think about how we could write this isPalindrome function recursively. Ooh. So, yeah, give you a minute and a little bit starting now, and then we'll see what we all come up with. Oops. Alrighty, anyone with any initial ideas? Yeah?
For the base case, the string length is 1.
So yeah, we could first write our base case. So you want me to use that string length function? So here I can create a variable called len equals string length of this. And then base case is if len is equal to 1. And then probably return true, right? Okay. S at 0 is equal to S at the last element, which would be len minus 1. Okay, yeah, so then I have to remove the first and the last element. In that case, right, this is a C string. So like I'd have to do like string copy or something like that. Seems like too much work. So can we do it without creating a copy of the string? Yeah. Yeah, I can add variables to this function if I want and call the other one a helper function. So I could do something like let's create some function called isPalindromeHelper, and then I can add some arguments to it. So I can add, what arguments do you want? Like how long it is, or the index, or what arguments do you want?
Are we assuming that we're like deleting characters, or we're just, because I was thinking like we first start with an index variable like 0, right?
Mm-hmm.
And then so your if statement would check s at 0 and then s at length minus 0 and you need to like 0.
Yeah, so we're kind of doing something like this, right? So I could try and add it so that these are both arguments, or maybe I could just have a string length argument, like the current length of the string I'm looking at, without trying to make a new one. For the interest of fun, yeah, let's do that. So we could create a variable called int length, the current length of the string we're currently considering, right? So we can always, so your idea was good, so we can just do your idea but move it into that base case, or sorry, move it into the helper. So in this case, we can replace it a little bit and then just say if the length is equal to 1, return true. Otherwise, sure, we can check the first characters. So if they are equal, like what you said, now I'm set up a bit better to give it like a smaller version of the string without having to copy a new one, right? So I could do something like the recursive call could be isPalindromeHelper s plus 1, so move it another character. And now I'm considering 2 less characters, right? So I remove the first one and the second one. So my length is essentially the length I had before, minus 2 now. And then pass that. If we get into this and they're not equal, then I know immediately that's also another base case where I know it is not a palindrome anymore, right? And then to kick it off, to start my helper, to kick it off, I could just do return isPalindromeHelper, give it the string of s, and then let's just do it directly, and then give it string length of s as the argument. So I could do something, let's get this out of the way. So I could do something like that. So my isPalindrome function calls isPalindromeHelper, which just adds another argument to keep track of the current length of the string. So I could give it, initially it starts off with, I can just use string length to figure out how many characters are in the string. And then here in the recursive function, my base case, I can consider the length is equal to 1, in which case it's a palindrome because it's a single character. Otherwise, I will check to make sure the first and the last character are equal. If they are, then I know it could still be a palindrome. I have to check the inner string, so I have to check the substring within. So in the case of race car, the first character and the last character are both R's. That's great. So I have to check ACECA. And I can do that recursively. If they'd never matched, so for the second call, it would compare, stop expanding. For the second call, it would compare B to C, and then know that, hey, those aren't equal. I don't have to check anything further. So everyone like that solution? Yeah?
Do we need to add another base case for if it's like a word with an even number of characters and we get to like a string length of 0?
Yeah, so there's one thing we did not consider, which is a good catch. Because we're subtracting the length by -2, we have to consider the case where, hey, what if our word is something like A, B, A? So, or sorry, if it is, sorry, A, B, B, something like that. So if it's an even number of characters, it's going to check A is equal to A. Okay, that's good. The new length to consider is going to be 2, so it's going to check B, B. And then that length is 2 minus 2, then it's going to be equal to 0, right? And we don't have a case explicitly for 0. And what's going to happen is, well, it's going to check, if length is 0, it's going to check s of 0 and s of -1, and that is an array index out of bounds, although not all the time. In this case, it would actually check a, so it wouldn't be in bounds, but it wouldn't be out of bounds, but it would be unexpected, and we would fail. So yeah, we can change our base case to just be less than or equal to 1 because if the length is 0, it's also a palindrome. We're not really considering anything. Let's call 0 palindrome. So we can do something like that. That should cover both cases. Oops. Oh, in the wrong directory. So compile that. Seems to be good. Try it out. Is palindrome. Oops. It just takes a string argument. So I can try race car. Says it is a palindrome. I can do this. Says it's not. A BBA says it is. Character A should just be palindrome. Seems to work. So any questions about that? So different way to solve it. So on the slides, you might have thought of it a different way. That's okay. We didn't need to make a helper function, but that would require making a new C string each time. Another way you could do it if you want to add more arguments is instead of just considering the length, I can just change or add the indices to the arguments. So what is the index of the first character? What is the index of the last character? So initially, the first character is going to be index 0. The last character is going to be that string length -1. And then my base case is if the first index is greater than or equal to last, so either they're both the same, so I'm comparing the same character, or because I add 1 to first and subtract 1 from last, could be the scenario where they cross each other. So if they cross each other as well, it's covered by this. So if the length is going to be 0, then we would go ahead, consider that it is a palindrome. Otherwise, we could also put these all in else if statements because only one of these conditions will be true at once. So if the two characters are not equal to each other, return false. So I kind of put my two base cases at the beginning in this case because there are direct return statements. And then else we do the recursive call. So we consider the same string, but we add 1 to the first index and subtract 1 from the last index. Again, multiple ways of doing the problem. Do whatever feels good to you. But any questions about that or recursion or anything so far? All right, let's go off on a little tangent then. So, following C features that apparently you shouldn't use for this course. However, you're allowed to, and if I tell them to you in a lecture, technically you're allowed to. So you may need to read them at some point or use them in the future. You're allowed to use them in your lab if you think it will make it more readable. So I've already seen some people ask about them, so we'll go over a whole bunch of different features. So the first one I've seen come up is the ternary conditional operator. So some people think, you know, an if, checking an if and then an else and then returning two different things is a bit of a pain. So there's another expression that you can use in place of an if statement that returns two different values. So it's done with the question mark operator. So the syntax is a conditional, so something that evaluates to either true or false, then a question mark, and then this is the value returned from that expression if it is true, and then a colon, and then the value returned from that expression if it is false. So that conditional has to be true or false, and then again, the value if it's true, and the value if it's false. So some examples of that, which are a bit silly because you should just return the value in this case, but I could write true, so true is always true, question mark 1 colon 0. In that case, the result of this expression will be the value if it's true because that conditional is true, so it will evaluate to 1. Similarly, with false, it will get the value, it will evaluate to the second value here, which will be 0. So these are ways to make your code a lot readable for very, very simple expressions. Otherwise, if it's not essentially one little line that returns one value, if it's something more complicated than that, I would say that an if and else is probably clear. But if it's something very, very short, this is okay. If it's something like this is a bit silly because you can just use the value true and false. So sometimes you get into that as well. So another thing, so we've went over that, hey, numbers are just, or sorry, any values on a computer, letters I type, anything like that, they're just assigned some magical number, and your computer just knows what it corresponds to. So you can give your own meaning to numbers with this type in C called an enum, short for enumeration, so something we just count a whole bunch of different options. So you can create your own type. So this is your own type. You can declare a variable of this type, and its syntax is enum and then a name. Typically, it's the name of what category you're trying to express. And then you can do set of curly brackets followed by a semicolon. And then you can have a bunch of named values. Typically, they're all capitals. And then you can optionally set them equal to some actual integer value. So that's the number you want C to use for that name. You can use as many as you want. And typically, you should define an enum just below the includes and not within a function. So it should go at the same level as the rest of your functions. So for example, if I was getting forgetful and I didn't want to remember which month corresponds to which number, I could create an enum for it. So how I would do that is I can create an enum. I'll just call it month. So typically it's all lowercase. And then I have my set of curly brackets and then all of the names. And typically these are just all in capital letters because they're essentially just big global variables that do not change. So I could define it like this, give every name. So January is 1, February is 2, March is 3, April is 4, so on and so forth. And then when you actually write your program that uses a month number, you can actually read it in English instead of just a number. So it's basically an int, but instead of it, you can use names. So if I wanted to check, write a function that says, hey, is this month in the winter semester? Well, if I didn't use an enum, I would have to remember all of the months and what their numbers are. And I don't know about you, but I took way too long to figure out what month number May is. So instead, you could write it like this, which might be a bit easier to read. So it's the winter semester if the month is equal to January, or the month is equal to February, or March, or April. And that way I could write a program. How you would use it is the type is called enum month. So I could create a variable called month, whose type is enum month. Then I can get my user to enter a month number, 1 to 12. So it's just an integer, so I can use the int format specifier here. It can fill it will assign it just like an integer, but now I can use it as its own type. So I could just say, hey, if is winter semester this month is probably in the winter semester, probably because, you know, sometimes April doesn't count depending on if you're done your exams or not. And then else I could just say this month is not in the winter semester. So that's another way you could try and make your code a bit more readable instead of just using magic numbers all the time. So typically you use this for categories. So another different one you could do is like create an enum that represents a direction. So I could create an enum called direction, create names for north, east, south, and west, and then I don't have to actually give each one a number. In fact, I don't have to give anyone a number. So the rules are if you don't specify an integer value, so I could just write north, comma, east, comma, south, comma, west, comma. If I don't do that, the first value listed is going to get the value 0. The next is going to get the value 1, then 2, then 3, until everything gets assigned a number. If I assign a value 1 here, that means this north definitely corresponds to the number 1, and the rest of them follow sequentially. So in this case, east will be equal to 2, south will be equal to 3, and west will be equal to 4. And they'll always go in order. So the above is exactly equivalent to, again, north is 1, east is 2, south is 3, west is 4. So we'll just do it in order. If you want to change the order, that will actually change what numbers they get assigned to if you do this. If you don't do that and you explicitly assign them, you can do it in whatever order you would like. So if I did that, I could create a function to print what value it represents, since at the end of the day, it is its own number. You can't just write your own printf format specifier, so you'd have to write your own function. So what you could do is write a function called like print direction that takes the direction as an argument. Again, its type in this case would be enum direction. And then you can check if the direction is equal to north, then print north. If it's east, print east. If it's south, print south. If it's west, print west. Otherwise, if it's not any one of these values, then just print exit failure because, well, your program has done something that it probably shouldn't have done. So there's another, so that looks a bit annoying, a bunch of else ifs where I'm checking the same value over and over again. So instead of many ifs that check a value, you can use something called a switch statement that uses the same variable and does something different depending on what the value of that variable currently is. And you can actually match a whole bunch of different values. So the syntax of a switch statement is switch, and then the variable name or value, and then a set of curly brackets, and then you have these weird things. So it says case, that's another keyword in C, case and a value, and then a colon. So this is not anything that executes. It's called a label. So if the value of this variable matches this value, your code will just jump to this label and start executing anything that is not a label after that. So C, again, skips to the case statement for the matching value and starts running that code. And the reason why it's somewhat discouraged is that it continues running, so it will go by any other case statement at all. The case statements just get completely ignored when it comes to execution. And it will keep on executing line by line either until it encounters a break statement, in which case it will go to the end of the switch, or until it just reaches the closing bracket of the switch. So if I want to do something, if the value isn't covered by one of my cases, then I can use the special keyword default and then a semicolon to represent where to go to if there is no match. Because otherwise, if there's no match, it just skips directly to the end. So sometimes you may want that. Sometimes you may actually want to do something if it does not match, in which case you would use that default. So if I wanted to rewrite the previous function using a switch statement, I could do something like this. So I could write print direction, enum direction, and then switch on D. That's the only time I have to use the variable D in this function. And then I can have separate case statements for every single value. So I could have a case statement for north, which would print F, and then print north, and then has a break. So it just skips to the end after it's done executing that print statement. Otherwise, if the value matches east, it would print east, then hit break, so it would make it to the end of the function and return. If I didn't have this break statement here, what would happen is if the current value of D is north, well, it matches this case statement, so C will jump here, execute printf north, and if this break isn't here, this is just another case statement. It'll continue executing and also print east. So it would also print east and then hit break and then skip to the end. So if I didn't have that break statement, if I just removed this first break statement here, if it matched north, it would print north and east, which probably wouldn't be what you want. So this is how I would rewrite it if I didn't want a whole bunch of if statements, and then like at the end where I had an else statement that if it didn't match, just exit my program. I could also do that in the default statement. So default, just exit my program. So any questions about that? different way we can go ahead and, if you don't like a whole bunch of, typically use this again if you're chaining a whole bunch of if statements together. So like if, some variable is equal to 1 or 5 or 7, then instead of checking all those, you can just use a switch statement. All right, another fun thing you can do, you can rename types with something called a typedef. So the syntax of a typedef is typedef, so the type you want to actually use, and then a new name for it. So you replace new name by the name of whatever type you'd like to create. So this would be the new type. And this first type keyword is the type you want to use whenever you use the name uname. So it's a way to set up a different name for a type if you want, which seems a bit silly at first glance. Like, why would you need to refer to a type by a different name? Well, one example that is slightly silly is maybe, for example, I could write typedef int and then call my new type number_t. So typically the convention is I just call the new type by something _t, which _t means it's just short for type. So we've kind of seen that before, that size _t, same idea with that. So with that, I could declare variables with the type number t everywhere in my program. And then later, if I decide, hey, all of those numbers I've been using, I want them to actually have a decimal point in them. So I could just modify in one place. I could change that typedef to instead be typedef double number_t. So now later when I recompile my program now, every time I use a variable with the type number_t, it is now a double when it used to be an int before. Saves you having to go back and try and change all of your types. So usually you append _t to the name to, again, indicate it is a type. So generally, creating a typedef for numbers is a bad idea. So if you do that example, so if I typedef int as number t and then did something like this, this would compile and be fine. But if I change the typedef to double number t, is anything bad going to happen in this program? So here we can oops. Yeah. Yeah, I didn't change the format specifier. So if I add A and B, well, the answer should be 5, right? But if I just go ahead and change that number_t to be a double now instead, well, you can see the compiler's already starting to complain at me because I forgot to change the format specifier to match a double now. So sometimes it doesn't work the way you want, because if I run it now and I do a plus b, I get negative some gigantic value because, well, now this format specifier, or this is actually a double now. So it kind of worked because C would just replace this with, 2.0 and 3.0. And then here, well, this would be double addition now, so we would get 5.0, but we can't print a double as an integer. We'll just get some random looking value, and it will be something we didn't expect. So that is something bad we could do. So one of the typical useful thing to do with a typedef is you might imagine writing enum direction all of the time with a space in there. Kind of looks ugly and might get slightly confusing, especially if you use the same name again. So the typical use of a typedef is to save us from writing enum, and it will save us writing the next keyword we are going to learn about as well. But how this works is Well, you're able to create an enum without giving it a name. By default, that's pretty useless because you would never be able to create a variable of that type since it doesn't have a name. But, however, I might write something like this. So typedef enum with curly brackets here. So this is the entire type. So it is an unnamed enum. And then I'm saying refer to that unnamed enum as direction_t. So after I do that, well, I can create a variable without using that enum keyword anymore. So I can create a variable with direction_t and call it direction equals north, which probably looks a lot more readable than like enum direction. So it makes a bit more sense that, hey, there's a type here without a space, and then the name of my variable, and then equals the enum value as before. So another way that I could go ahead and have something a bit more readable, this is a very standard trick you will see in C all of the time. All right, so any questions about those little tricks? Just more little tricks. If you want to use them, again, feel free to ignore them. All right, other than that, wow, we burned through that. So as a final exercise, we can end off the class going back to recursion. So can we implement something like stir_car recursively? So let's see here. So just as a reminder, let's go here. Stir_char, that function should search for this character in this string and then return a pointer to the first instance of that character. Otherwise, if it can't find it, it should just return a null pointer. So I'll let you go ahead and ponder this for, you can work with your neighbor. We'll do like 2 minutes and then we'll come back to it and see if we can write this again. Typical thing we do on finals and things like that. Writing recursive functions with strings, always a fun topic. You'll see tons of examples in the past exams. So go ahead, try that out. Oh, yeah?
Can I modify the header?
Okay. Modify the header?
Like, or add an argument.
What do you want to add? Oh, like to the function?
Yeah, like just to clarify, like you want to find if the character C exists within S.
Yeah. So so stir_car, what it should do is, let's see if we get documentation. Not really.
Okay, never mind.
Yeah. So stir_car should return a pointer to the first instance of the character in the string. Yeah. If it's not found, it should return null. Yeah, so in this little test case here, if the C string is pointing to is hello with 2 L's in it, and we're searching for the character L, it should return me a char pointer pointing to the C string pointing at the first L, so here. So if I print as a C string, it should be LLO. So if I run it, well, if I compile it, my other function shouldn't return anything, so return null. So if I run this, what do I call it, recursive? So it should return LO, and right now, my function right now just returns null because, well, that's my entire definition of it. Ow. Alrighty, any thoughts for this one? So we might have to go back and think about what makes up a C string too. Yeah.
For the base case, if the string length equals 0, then return null. And then also,
So if the string length is 0, return null. So that's one base case, yep.
and then the second one, also s at 0 equals c, then return s.
Yeah, so see, I have two base cases now. So one, don't always have to have exactly one base case, so that's what this is showing. So if the string length is 0, return false. I've made it to the end. I'm not actually looking at anything, so there's no character to actually match. Otherwise, if the first character matches the character I'm looking for, just return s. I found the first instance, and then last one.
For the first if statement, it should return null.
Oh, return null, sorry.
And then for the recursive step, else, return the method call, but at s plus 1.
Yeah, so my recursive step is going to be call itself with s plus 1. So that skips forward one single character. So in this instance, the smaller version of the problem I'm breaking it down to is I'm checking the first character, and then if it matches, great. If it doesn't match, I go to a smaller string with the first character removed. So I don't need to change C. I'm still looking for the exact same character, and I should have a return statement here. Otherwise, it is not going to work. So everyone like that one? So if I compile and run it, works. So again, different ways to write it. This is a perfectly good way to write it. If I consider just, the first character, another way to consider the first character, something that means the same thing, is instead of the array index notation, if I didn't like it for whatever reason, in this case I would argue it's probably actually better, but I could also just dereference s, right? And that will just give me the character I'm currently pointing to. Means the same thing. And then if I didn't want to use C string for whatever reason, the other thing I could do is look at the character, and if it's equal to the null character, then it means I'm at the end of the string too as well. So two different ways to do that. String length will do it as well. But if the question for whatever reason said you can't use stir length, which I don't know why it would, again, you should always remember what a C string is, just an array of character that is always terminated by a 0 or that null character, which is just that special value 0. So if I compile and run this as well, still works, still good. Another case of recursion. So any other questions from today? Otherwise, we can enjoy a nice spring day because we did that in record time. Nope. All right, I will hang around then for a little bit if you have any questions or anything like that. But otherwise, good job. And just remember, I'm pulling for you. We're all in this together.